Let us look at page 1, 2. Page 1-2. We are going to look at the first example on page 1, 2. On page 1, 2, in example 1, you are given two vectors A, which is minus 3, 4, 0, and then another vector B, which is 5, 12, 0. Right? In this example, you are given these two vectors A and B. Now, in part 1 of A, the aim of part 1 is to find the sine of the angle between A and B. To find angle or to find something about the angle between two vectors, usually most of the time we want to use the dot product. So let's revisit the dot product. What is the meaning of A dot B? If you could recall, by definition, A dot B, right? The dot product A dot B is equals to modulus of A, modulus of B, cos of theta. This is the definition of dot product that you know of from your lower years. Alright? So, so if you want to perform the dot product of two vectors A and B, according to the definition, you need to know the modulus of A and the modulus of B, and then follow with cosine of the angle between them. This is the right hand side. On the left hand side, we have learned that to find A dot B, there's actually a way to find A dot B by taking this times this plus this times this plus this times this. So on the left hand side, I will perform the dot product by doing this times this plus this times this plus this times this. And if you do this, you will get a value of 33. And then you want to find the modulus of A. How do you find the modulus of A? If you could recall, to find the modulus of a vector is you find the square of this, square of this, the square of this, and you add them up together, and you square root it. If you do that arithmetic, you will get 5. Likewise, to find the modulus of B, you square, add up together, and you square them, you get number 13. And then cos theta. So by performing the dot product, we are able to find the cosine of the angle between the two vectors, and this gives me 33 over 65. But for part 1 of this question, the intention is to find the sine of the angle between them. How do you find the sine of an angle from this cosine? Do you remember our trigo identities? This is 1 minus cosine square theta. Let me write carefully. This is square. Right, this is square. Right. So you just have to perform this arithmetic. 1 minus the square of this number, tidy up, and then you square root that arithmetic, you will get 56 over 65. So that resolves the first part 1, finding the sine of the angle between the vectors A and B. Part 2 wants you to find a vector, a unit vector that is perpendicular to A and B. I want you to recall, what is the meaning of a unit vector? A unit vector is actually a vector whose magnitude is 1, right? As long as your magnitude is 1, you qualify as a unit vector. Now in part 2, we are required to find a vector which is unit, and at the same time it is perpendicular to A and B. How do we do so? Now, you want to recall that in my previous video, I showed you a diagram how the vector A and B are aligned. if this is the x-axis, and this is a y-axis, and then this is a z-axis, right? If you could recall, A is a vector that is somewhere here. A is somewhere here, somewhere there. B is somewhere like this. Right? This is a vector A, and this is a vector B. You want to also realize that in this case, the vector A and B actually lies on the xy plane. XY plane, you just imagine the XY plane as a horizontal plane, and in this horizontal plane, there's a vector A and B, and perpendicular to the XY plane is the z-axis. So in this case, if you are asked to find a vector which is perpendicular to A and B, judging from this diagram, an obvious choice would be a vector that is up this way or down this way. So in fact, there are two choices that you can pick. A vector that is perpendicular to A and B and is a unit vector, you could potentially pick a choice of 0, 0, 1 or 0, 0, minus 1. The only difference is 0, 0, 1 is a vector that goes up. 0, 0, minus 1 is a vector that comes down. That's the only difference. And both of them are perpendicular to both 0, 0, 1 and 0, 0, minus 1. They are perpendicular to A and B. Now in part 3, right? In part 3 of the question, you're asked to find this. You're asked to find or compute A cross B. Okay, from the previous video, you have understood that cross product is a new arithmetic, something new for you. By definition, cross product is just modulus of A, modulus of B, sine theta, and n cap. So there are 4 things that we need in finding the cross product. We need the modulus of A, the modulus of B, and then sine of the angle between them, and then the n cap. So the modulus of A, how do you get the modulus of A? This is a vector A, and the modulus of A is just 5. Remember? We just square, added together, and then we square it. And B is 13. We have already found the sine of the angle between them, which is 56 over 65. And now we come to this n cap. The definition of n cap in the case of cross product, n cap in this case represents a vector that is perpendicular to both A and B, and n cap must be a unit vector. So in fact, we have 2 choices. However, I want you to realize that in the case of cross product, there's also the so-called rule to follow. In finding the cross product of 2 vectors, A cross B, you have to put your hand like this, and you curl your finger from A towards B, where your thumb lies, where your thumb is pointing. That is the direction of n cap that you want to use. Once again, cross product requires you to use so-called the right hand rule, that as you cross from A to B, cross product, right, you curl your finger from A towards B, the direction of thumb is actually the direction of the vector for n cap. So in this case, we therefore have to choose a vector that is coming downwards, like this. So therefore, between the 2 choices of 0, 0, 1 and 0, 0, minus 1, we have to choose 0, 0, minus 1, right? So the choice of n cap is actually picked like this. So therefore, my n cap would be 0, 0, minus 1. And then upon performing your arithmetic, you would get 0, 0, minus 56. So what we are saying here is, if you cross product A and B in this case, A cross B, you will get a vector in this case 0, 0, minus 56, which is a vector that's somewhere like that, something like that. Right? This is the vector 0, 0, minus 56. Okay? I want you to note something. This vector is in the same direction as n cap. Can you see? This red color is an n cap. This is a vector, the overall A cross B, right? And this vector is in the same direction as an n cap. And because of this, it is not hard for you to see that this resulting vector is also perpendicular to B and also perpendicular to A. Okay, I'm going to draw it. I hope that helps. Okay, right. So this vector, the resulting vector of A cross B, is a vector that's here, and it is perpendicular to both B and A. So this is actually your so-called part 3. And then part 4 of the question wants you to find the modulus of A cross B. To find the modulus of a vector is square, square, square added together, square rooted. In this case, you will get an answer of 56. Now, could you turn with me to page 12? Page 12. Okay, a small exercise there. There's an exercise there on page 12. Part 1. A dot A cross B. Part 2. B dot A cross B. Okay, in this small exercise, give yourself the 30 seconds to ponder over this arithmetic. What should it be? Okay, you want to recall that when you have a dot product, in the case of dot product, you want to recall that if you have a vector dot with another vector, and if these two vectors, right, A is here, and then A cross B is here, okay? A cross B is here, right? If these two vectors are perpendicular, make right now, okay? This is actually A cross B, okay? A cross B. Right, judging from this diagram, the vector A and A cross B are perpendicular. So we learned that if two vectors are perpendicular, the dot product will be 0. Likewise, B is also perpendicular to A cross B, so this dot product is also 0. Okay. Then on the same page, right? We want to talk about the first property of vector product. In the first property, it says if two vectors A and B are parallel, then what we want to say is the first property is A cross B will be. I want to highlight to you this symbol represents a vector. So what we are saying here is if two vectors are parallel, the cross product is a 0 vector. Do not mix this up with this. This is just a numeral 0, where this is a 0 vector. In a 3-dimensional space, a 0 vector actually looks like this: 0, 0, 0. Let us ask ourselves this question: why should two vectors which are parallel gives a cross product which is a 0 vector? Why should this happen? Okay, let us look at the definition of cross product. If two vectors are parallel, then the angle between them will be. Say again, if two vectors are parallel, what can you say about the angle between these two vectors? It is either 0 if they are in the same direction, or it is 180 degrees if they are in opposite direction, right? So when two vectors are parallel, this angle is either 0 or 180. And we know that if this angle is 0 or 180, sine 0 or sine 180, right, will be 0. And this makes this whole thing 0, and you have a 0 times a vector. A 0 times a vector will give you so-called the 0 vector. That's why when two vectors are parallel, the cross product will be a 0 vector. That brings us to the conclusion that whenever you have two parallel vectors, the cross product will be 0 vector. To highlight to you, one thing is, while this does imply this, right? Do you think that if A cross B is 0, if A cross B is 0 vector, do you have implication in the other direction? So I'm asking you, if A cross B is a 0 vector, does it necessarily mean that A and B are parallel? If two vectors have a cross product of 0, then either they are parallel or one of them is a 0 vector. One of them. So very careful, no? Well, one direction is for sure, which means if two vectors are parallel, for sure we have this. But if you have this result, the implication in direction is a bit tricky, in that if this is a 0 vector for a cross product, then it only means that the two vectors are parallel, or number 2, one of the two vectors is a 0 vector. Alright, so in the other direction, the implication is slightly different. Let me write some properly. I want to write this number 2. This number 2. Okay. And now we want to do a simple exercise right below on the same page. The exercise on the same page asks you to find. Okay, the exercise below asks you to find what is I cross I. Because I and I are the same vector, therefore they are parallel and in the same direction. And because they are parallel, then from the earlier result, this will give you a 0 vector. Likewise, if you take J cross J, because they are parallel and in the same direction for this case, again you get 0 vector. And likewise, if you have K cross K, you also get a 0 vector. This is on page 113. Okay, this is page 13. These are all found on page 13.